Right, so this is the second section of the tube. This is the second section of the tube. Right, so here I just answer question number 11 and 12 only. It means I just answer 2 questions per section. I just want to recall your memory. That's all. Right. The question number 11 asks, the following objects are moving along a smooth horizontal surface. Find their accelerations. The following objects are moving along a smooth horizontal surface. Find their accelerations. Right. Let's give a try here. The mass of the first object is 10 kilogram. The force acting on it is 20 newton. So we just apply F equals ma. The force is 20, mass is 10, acceleration is simple a. By cross multiplication, I can take 10 to the side of 20. So the equation will be simple a only will there, 10 will be at this side, 20 divided by 10. 20 divided by 10 is 2. So we got the answer as 2 equals a, but we should write one more step. We should write a equals 2 meter per square seconds. Please complete this here. This is the answer for question number 11, Roman number 1. Quick. Question number 11, Roman number 1. Complete it quick. Is video clear here? Can you see the board clearly, Lamai?
Yes, sir.
Right, thank you, dear. Right, shall we go to the second question here? I'll give the answer here. Shall we go to Roman number 2? Right, how many forces are acting on the second object? How many forces? 2 forces. What are the directions of the forces? Are they acting into the same direction or opposite direction?
Same direction.
Then when we say F equals ma, in the equation F equals ma, F is the resultant force. For this case, resultant force is summation of the 2 forces. As forces are acting in the same direction, the resultant force is the summation of the 2 forces. We should indicate it like that. Mass of the object is 12, acceleration is simple e. Can you do the rest and find the acceleration here? Right? So you should remember that in this F equals ma equation, F means the resultant force. F is the resultant force. Got it? F is the resultant force. Do not forget it. Right? Please write here. So here the resultant force is the summation of the 2 forces because they are acting in the same direction. As they are acting in the same direction in this equation, resultant force is the summation of the 2 forces. So 4 plus 2 is 6 equals 12 times 8. So in the next step, we can take this multiplication 12 into the other side as division 12, right? So it will be 6 divided by 12. 6 divided by 12 equals simple. Got it? So 6 divided by 12 is half. So it's very much clear. 6 divided by 6 is 1. 12 divided by 6 is 2. So A equals half. 1 equals 1 divided by 2. 1 divided by 2 means, what's the answer here? Half means, Lamai? 1 over 2 is 0. 10 divided by 2 is 0.5 meter per square second. So this is the answer. Is it clear for clear all of you, dear? Right. So please remember that whenever they have given the equation F equals ma, it means the resultant force. F means the resultant force. In Roman number 2, both forces are acting in the same direction. Therefore, the resultant force is the summation of the two forces. The resultant force is the summation of the two forces. Okay, dear? Right. Shall we go to question number 3? Who wants more time to write the things, dear? Tamal? Right. Let's go to question number 3. Right. For the Roman number 3, let me apply the equation again. F equals NV. Right. Now, somebody unmute the mic and tell me the number of forces acting on the third objective.
2, sir.
2 forces. Are they acting in the same direction or opposite direction?
Opposite directions.
Opposite direction, sir.
Then what is the resultant force here?
20 Newton minus 60 Newton, sir.
Yeah,
minus
very
60.
good. Bigger force minus smaller force. So what is the resultant force? Very good. 20 minus 16. 20 minus 16 is the resultant force. Mass is 4. Acceleration A. So 20 minus 16 is 4 equals 4 times A. 4 times A. So 4 and 4 cancel. 4 divided by 4 is 1. Therefore, what is the acceleration? Somebody under the mic can tell me here.
1 meters per square second, sir.
1 meter per square seconds. Very good. Please try them all. Very good here. 1 meter per square seconds. Complete here. Right. I have discussed question number 11. I want to go to question number 12. Once I discuss question number 12, I will go to section of the same tube, and I just discussed 2 questions. So I just want to recall your memory. That's all. That's what I want. Right. Who wants more time to write with answers? Anybody in the class? May I go to question number 12 now? Is the time enough for you to write? Okay, then I'll go to question number 12. I'll erase them all. If you want to take a screenshot, I'll erase them all and I'll go to question number 12. Right, somebody unmute the mic and read question number 12. Start. Somebody unmute the mic and read. I said an object of mass 2 kilogram moving on a raft. What is the meaning of raft here?
It has frictional force.
It has frictional force. That's the meaning. Raft, horizontal surface mean friction forces are acting on the object. That's the meaning. Right. With the constant acceleration of 0.2 meter per square second. So, by a horizontal force of 6 Newton. So, what are the given data here? Surface is rough. Surface is rough means there should be friction forces. There should be friction forces. So, first of all, I should mark the friction force. The friction force acting on the object, I have marked into this station. In addition to the friction force, weight, the gravitational attraction force, which is known as weight of the object acting downward. In addition to the gravitational attraction force, there must be normal reaction force, which is given by the surface. Right? So let me use a different color pen and draw it. The reaction force given by the surface to the object. Right? Like this. And what is the mass of the object here? 4 kilogram. Please draw this figure. Please draw this figure quickly. So this is the friction force. So I use Fr. Fr Newton is the friction force acting on the object. Can you? I think you are able to see the board clearly, right? Then the weight of the object. Then the weight of the object should also be marked. Weight of the object is mg. Mg Newton. Sometimes it is called weight of the object, sometimes, but actually it is the gravitational attraction force given by the Earth. We call it as the weight, but the best term is the gravitational attraction force given by the Earth. Then let me mark the normal reaction force. The normal reaction force. Normally it is indicated as capital R Newton. Capital R Newton. So please mark them here. Quick. Draw the figure and mark the forces acting on the object. they have given us the acceleration also. Acceleration of the object is given as 0.2 meter per square seconds. This is also given. Mark them already. There are two methods to find friction force. There are two methods to find friction force. Here acceleration is known. So as acceleration is known, I'll use the equation F equals mv. Look at board name. I'll use the equation F equals mv because acceleration is given, acceleration is known. Now somebody unmute the mic and tell me, I'm going to apply F equals ma along the horizontal direction. F equal ma along the horizontal direction. That's the point. Along the horizontal direction. Right. Somebody tell me how many forces are acting along the horizontal direction here.
Two forces.
Two forces. Are they acting in the same direction? No, opposite directions.
Opposite direction.
Opposite directions, sir.
Very good. They are acting in the opposite direction. They are the resultant force. It is the resultant force. Now resultant force is 6 minus Fr. Fr is the friction force. Equals mass of the object is given as 2 kilograms. Acceleration is given in the question as 0.2. Acceleration is given as 0.2. Can you do the rest of the simplification and tell me the answer here? And send your answers to Zoom chat. Please do the rest of the simplification. Send your answers to Zoom chat. From this equation, you can find Fr. Fr means friction force. Send me the value of friction force. Start. It's so simple, right? So I'm not going to do anything to 6. Actually, we can't do anything to 6. And we cannot do anything to Fr equals 4 into 0.2. 4 times 2, 8. But there should be a decimal place. So it is 0.8. 0.8. Right? So next step, I'll take this 0.8 to the other side. Plus 0.8 comes to the other side as minus 0.8. Minus Fr goes to the other side as plus Fr. 6 minus 0.8 means 5.2 equals Fr. but we never keep an answer like this. We should keep the answer as FR, friction force, equals 5.2, then we should write the unit. So we should always keep the answers in this format. FR equals something. We do not write a number equals FR, that's something. That's really, really complete here. Who got this answer? FR equal 5.2 Newton. Lamai? Right. What's the other equation? What's the other equation that can be used to find friction force? We have learned another equation to find the friction force. What is it?
Friction force equal to mu r.
Friction force equal mu r. Mu is the constant. What's the name of the constant? What's the name of the constant mu? It is called coefficient of friction. What is it called here? Lamai?
Coefficient of friction, sir.
Very good, very good. Coefficient of friction. Here, look at board here. Who gives this mg force? Who gives this simple mg force? Let's say this object is kept on a table. Let's think this object is kept on a table like this. Table is kept on the earth. Who gives this simple mg force?
Earth, sir.
Earth, very good. Simple mg force is given by the earth. Who gives capital R force here?
The surface.
The surface of the table. The surface of the table. If R force is larger than mg force, what will happen to the object? Will it be moved or not? Sorry, dear?
The object moves upwards, sir.
Very good. If capital R force is larger than mg, the object will be moved up. If mg force is larger than R, Lamai, what will happen?
The object moves downwards.
The object moves downward. If mg force is larger than R, it will be moved downward. If R and mg are equal,
The object will be at rest.
it will be at rest. So object will not be moved upward, object is not moving downward, it is moving only along the horizontal direction. Therefore, R and mg forces should be the same. Star pointer right. Star pointer right. There is no motion along the vertical direction. Star pointer right. There is no motion along the vertical direction. Therefore, there is no motion along the vertical direction. Therefore, upward force should be equal to the downward force. There is no vertical motion. Full stop. Therefore, upward force should be equal to the downward force. Right. So leave a line and write. Then upward force is R, downward force is mg. So R equals mg. So mg is 4 kilogram, g is 10. 4 times 10 is 40 Newton. Got it here? So we have found the normal reaction force. Complete it. We have found the normal reaction force. Normal reaction force is given by the surface on which the object is kept. Okay? The normal reaction force is given by the surface on which the object is kept. Okay, dear? Capital R is the normal reaction force. Capital R is the normal reaction force which is given by the surface on which the object is kept. Capital R is the normal reaction force given by the surface on which the object is kept. Kept. Right now, I'm going to use the second equation for the friction force. Friction force equals mu r. I use the English letter U to indicate mu because I don't have any other way. I don't have Greek letters in this keyboard, right? So we have already found that friction force is 5.2 Newton. Mu we don't know. R is 40, right? So by using this equation, we can find the mu. I have indicated English letter U, but it's, you should use the Greek letter mu for it. Can you find the value of mu and send me your answers to the group chat here? Zoom chat. So if you take 40 to this side, let me take 40 to this side. So multiplication 40 come to this side as division 40. So 5.2 divided by 40. 5.2 divided by 40 equals mu. Got it? So what can we do here? How do we simplify this? The easiest method is this. Look at board here. I can divide 5 by 4. 5 divided by 4 is 1 point. 5 divided by 4 is 4. 5 minus 4 is 1 remaining. Then 12 divided by 4 is 3. So if I divide 5.2 by 4, answer is 1.3. If I divide 40 by 4, answer is 40 divided by 4 is 10. Sorry. So what have I done here? I have divided both 5.2 and 40 by 4. Okay. Then 1.3 divided by 10 is 0.13. So mu is known as the coefficient of friction. We have found it answer as 0.13. What's the unit of mu here? Somebody unmute the mic and tell me what is the unit of mu?
No units.
No units.
No.
Very good. No units. No units. Somebody please unmute the mic and read the question once again. Question number 12. Somebody please unmute the mic and read one more time.
An object of mass 4 kg is moved on a rough horizontal surface with constant acceleration of 0.2 meters second minus 2 by the horizontal force of 6 Newton.
Thank you, dear. Thank you very much. An object of mass 4 kg is moved on a rough horizontal surface with a constant acceleration of 0.2 meter per square seconds by a horizontal force of 6 Newton. So what are things that they have asked? As I remember, they have asked us to find the coefficient of friction. And as I remember the things that they have asked. Yeah, the coefficient of friction. Find the coefficient of friction and find the friction force acting on the object and the coefficient of friction. So what are things that they have asked? I think you can barely read this question. Find the friction force acting on the object and the coefficient of friction. Okay, dear? Right. So the complete answer to the question is here. If you want, please take the screenshot. If you want any more time to write the answer, please take the screenshot. The complete answer is here. Okay, shall we go to question number 13 also? I think it will be a help if I discuss question number 13, because sometimes you may have forgotten about the tension forces in the string. May I discuss question number 13 also, or are you okay with it? No answers, right? I'll list everything and I'll go to question number 13, right? But I'm not going to discuss more than question number 13. I'll go to another section just after I discuss question number 13, right? I use the letter U for the instead of mu because I do not have the letter mu in my keyboard. As I cannot type mu, I use the English letter U. So if you are really upset with it, just make it mu by drawing a line like this, if you want. Okay, those things are not problems, right? Right. Let's go to question number 13. Right. Somebody unmute the mic and read question number 13. Start there. Read all the things, all the questions, including Roman numbers.
Two objects are connected by a light inextensible string and they are moved on a smooth horizontal surface by a horizontal force as shown in the figure. Roman 1. Find the acceleration of the system. Roman 2. Draw the free force diagram of the object and the string. Roman number 3. What are the tension forces acting at the end of the string?
Right. Thank you, Budam. Two objects are connected by a light inextensible string and they are moved on a smooth horizontal surface by a horizontal force as shown in the following figure. Find the acceleration of the system. That is a very simple question. We can find the acceleration at once. Look at board here. So to the system, look at board. To the entire system, to the system, I'll apply F equals mA. So here F is resultant force. F is resultant force equals here M is resultant mass and A is acceleration. So those are the things that you should understand. Right. So here, what are the things here? What are the terms? Right. If you apply F, if you say you are applying F equals MA to the system, the meaning of F is resultant force, the meaning of M is resultant mass, and so on. Resultant force. What is the resultant force here? The total force acting on the object here. Lamai. The only force acting on both objects 18 Newton. Therefore, the resultant force is 18 Newton. Equals, what is the resultant mass there? Acceleration we don't know. Somebody
9 kilograms.
can tell me resultant mass.
9 kilogram.
9 kilogram. mass of the first object plus mass of the second object. That is the resultant mass. Please write all the things as I have written and find the acceleration. Simple A. Start. No need to draw a figure, right? No need to draw a figure. Figure is there. Just write this equation and find the acceleration here quick. And send your answers to the Zoom chat. Send me your answers of simple A to the Zoom chat. Right, many of you have sent me the correct answer. I'm so happy with your answers. So 18 equals 3 plus 6 is 9 into simple A. So if I take 9 to the other side, if I take 9 to the other side, it will be 18 divided by 9. 18 divided by 9. Multiplication 9 goes to the other side as division 9. So 18 divided by 9. 18 divided by 9 is 2. So it means simple A. It means simple A equals half. 18 divided by 9 is 2. 2 meter per square seconds. Who got this answer, Lamai? Who got this answer? Please raise your hands up. Everybody please raise hands up if you have obtained this answer. Right, very good. Please take a screenshot if you want any more time to write these things. Please take a screenshot because I am going to go to Roman number 2. I am going to go to Roman number 2. So therefore, if you want any more time to draw the things, please take a screenshot. Right. Roman number 2. Draw the free force diagrams of the object and the spring. Free force diagrams. I would like to use whiteboard to explain free force diagrams. Right. I would like to use my normal whiteboard. If you want, you can take a screenshot of this one. This is the second friction of 600 friction tube. I'm going to erase and I'm going to use my normal whiteboard to explain free force diagrams. Look at both free force diagrams, free body diagrams, same meaning, right? Let's see. Okay, look at both. So what are the masses that they have collected? 3 kilogram and 6 kilogram. There are two objects. There are two objects of 6 kilogram and 3 kilogram. This is 3. And 6 kilogram. They are kept on a smooth horizontal surface. It means no friction forces. A force is applied on the 6 kilogram, that is 18 Newton. They are connected by a spring, light, smooth, and a horizontal spring. We found that all these objects moving with an acceleration of 2 meters per square seconds. Right. Now I'm going to draw the free body diagrams. First of all, I have drawn the normal figure given in the question, and now I'm going to draw the free force diagrams. Right. My question is, listen, I'm going to ask few questions before I draw this figure. Right. This 6 kg object is moving to my right hand side. Why is this object moving to right hand side? Somebody tell me why it is moving into the right hand side.
Because of the 18 Newton force.
Very good. Because of the 18 Newton force. So there must be a force for any object to be moved. For any object to be moved, there must be a force. This 6 kg object is moving into the right hand side because of the 18 Newton force. So if I draw this 6 kg object, it is moving into the right hand side because of this 18 Newton force. That's why it is moving into the right hand side with an acceleration of 2 meters per square seconds. My second question is, if I consider this string, right? If I consider the string, why it is moving to the right hand side? Same logic. For any object to be moved with an acceleration, there must be a force. The string is moving to my right hand side with an acceleration. Therefore, there must be a force acting on the string. The string is connected to the 6 kg object. Therefore, when the 6 kg object is moving right hand side, it pulls the string. So let me mark the force acting on the pulley force as F1. Who gives this F1 Newton force here? F1 Newton force is given by 6 kg object to the string. Right? Now somebody tell me Newton's third law of motion.
Every action has an equal and opposite reaction.
Every action has equal and opposite reaction. Very good. So F1 force is given by 6 kg object to the string. Why? String and 6 kg object are connected together. So when the 6 kg object is moving to the right hand side, it pulls the string with the force of F1. Every action has equal and opposite reaction. Therefore, when 6 kg object gives a force of F1 Newton to the string should give equal and opposite reaction force. So I'll instead of using F1, let me use that letter T1. So T1 is the force given by the 6 kg object to the string. Then the object gives equal and opposite force of, let me mark it as F1. Let me explain again. The string and 6 kg object are connected together. Therefore, when 6 kg object is moving to one direction, 6 kg object pulls the string by a force of T1. Because of that T1 force, the string is moving into the right hand side. So T1 force is given by 6 kg object to the string. Right? Every action has equal and opposite reaction. Therefore, when 6 kg object gives a force of T1, the string should give equal and opposite force. Then this T1 and F1 are called action reaction forces. Action, reaction forces. Action, reaction forces. So please do not forget action, reaction forces. So my next question is about this 3 kg object, right? So who gives a force to this 3 kg object to be moved? Because even the 3 kg object moving right hand side with an acceleration of 2 meter per square seconds. For this 3 kg object to be moved into the right hand side with an acceleration, there must be a force. Who gives that force?
The string.
The string.
String.
As the string is connected to the 3 kg object, when the string is moving right hand side, it pulls 3 kg object. It pulls 3 kg object by a force of F2 Newton. By a force of F2 Newton. Who gives this F2 Newton force? The string. Why? The string is connected to the 3 kg object. String is connected to the 3 kg object. So once the string is moving to a certain direction, it pulls the object with it. So the string pulls the object by a force of F2 Newton. Then 3 kg object moved right hand side with this acceleration because of this F2 Newton force. Again, somebody unmute the mic and tell me Newton's third law of motion. Somebody in the class.
Every reaction has an equal
So
and
every
opposite
action has
reaction.
an equal and opposite reaction.
Every action has equal and opposite reaction. So when the string gives a force of F2 Newton to the object should give equal and opposite force to the string. Am I right? When the string gives a force of F2 Newton to the object, right? The object should give equal and opposite reaction force to the string. So let me mark that force as T2. Let me mark that force as T2. So they are again called action, reaction forces. Right, got it? In addition to these forces, I just marked two more forces. The weight of the 6 kg object acting downward as m1g, which is given by gravitation attraction force of the earth, and the surface, the force given by the surface, which is known as normal reaction force. Let me mark it as R1. So here the gravitation attraction force acting this object is into G Newton, and the force given by the surface is R2 Newton. Force given by the surface is R2 Newton. It is known as normal reaction force. So I have marked all the forces acting on all the objects. This kind of diagrams are said to be free force diagrams and free body diagrams. You can use any terms. The string is a light string, no mass. When an object does not have a mass, the weight of that object is 0. Therefore, I have not marked the weight of the string as m3g. We do not mark it because string is said to be light. It means no mass. Please draw both figures and try to memorize. So I have completely taught these things in my theory class. This is the paid class. So if you have not learned these things, just send me a message to my WhatsApp after the class, but not now. Right? Draw them all here, quick. Right, I think time is enough for you to draw this figure. Right, so these T1 and T2 are known as tension forces acting on the spring. These T1 and T2 are known as tension forces acting on the spring. So as action and reaction forces are equal, F1 equal T1, F2 equal T2. So the first thing is that action force equals reaction force. They are equal in magnitude. Therefore, action and reaction forces are equal. So therefore, F1 equals T1 and F2 equals T2. F1 equals T1 and F2 equals T2. Got it? So if I found the value of F2, that is equal to T2. If I found the value of F1, it means that is T1. They are equal, right? So look at board. I'm going to apply F equals MA only to 3 kg object. Only to 3 kg object, I'll apply F equals MA. The only force acting on the 3 kg object is F2. The only force acting on the 3 kg object is F2 along the horizontal direction. Therefore, F2 equal mass of the object is 3, acceleration is 2. So it means F2 equals 6 Newton. So if F2 is 6 Newton, then we can write in that therefore T2 is also 6 Newton. Got it? Write them all here. If you have any doubts, send me a message to Zoom chat or just unmute the mic and ask. Right, now we want to find this T1. Actually, the string does not have a mass. The string is massless. When a string is massless, the tension forces should be the same. T1 and T2 will be equal. T1 and T2 will be equal. But let me prove that. Let me prove it that T1 and T2 are equal. So I'll do something like this. I'll apply, look at board, only to 6 kg object. Only to 6 kg object. To this direction, I apply F equals MA equation. Somebody unmute the mic and tell me the number of forces acting on 6 kg object along the horizontal direction. Lamai, someone?
Two.
Two forces, very good, two forces. So F is the resultant force. Two horizontal forces are acting on the object. Therefore, the resultant horizontal force is, as they are acting into the opposite direction, 18 minus F1. They are acting into the opposite direction. Therefore, difference of the forces is the resultant. Mass of the object is 6. Acceleration of the object is 2. So 18 minus F1 equals 6 times 2 is 12. So I'll take plus 12 this side as minus 12, minus F1 goes to the other side as plus F1. So 18 minus 12 is 6. So it means F1 is 6 Newton. Therefore, T1 should also be 6 Newton. So T1 and T2 are the tension forces at the ends of the string. As there is no mass, as the string is massless, T1 and T2 are equal. Both are 6 Newton. Both are 6 Newton. Complete the note. Write them all here. Start. If you have any doubt, just unmute the mic and ask. I can help you. Shall we give a try? Shall we give a try for the next question? Can you see my screen here?
Yes, sir.
Yes, sir.
Question number 14. Somebody unmute the mic and read question number 14 for all of us loudly.
A box of mass 20 kg is kept on a smooth horizontal surface. Another object of mass 16 kg is kept on the box. The two objects are connected by a light inextensible string, and the string goes over a smooth pulley. If a force of 6 Newton is applied on the box, as shown in the following figure, Find the acceleration of the box.
Okay, very good. Please check whether you see that. Did you notice this term here? A box of mass 20 kilogram is kept on a smooth surface. What does it mean, dear? Smooth.
No friction.
No
No
frictional
friction
forces.
force.
No frictional force.
Very good. Another object of mass 16 kilogram is kept on the box. The two objects connected by a light. Light mean, what does it mean, dear?
No mass.
No mass.
Light means no mass. Inextensible mean
Unstretchable.
Unstretchable.
unstretchable. You cannot increase the length by applying forces. Right. Then goes over a smooth pulley. What is the meaning of smooth pulley, dear?
No friction.
No frictions.
No friction. If a force of 6 Newton is applied on the box as shown in the following figure, find the acceleration of the box. Now you see, dear. Now you see, there are no friction forces. So as usual, let me mark the tension forces acting on the string. Light string means if the tension force here is T Newton, what should be the tension force at the other end here? Here.
T newtons.
T
So
Newton.
same.
The string is massless, therefore tension force at the other end should also be capital T Newton. No friction forces are acting on the system. Got it? Right. I would like if you take a screenshot. And the other thing, please draw this figure. Please draw this figure with this T Newton and T Newton. Please take a screenshot also. And I have a question to ask. Right. If this object, this 20 kg object is moving to my your left hand side with an acceleration of simple a. If this 20 kg object is moving with an acceleration of simple a, right? What should be the acceleration of this 16 kg object here? Somebody?
Yes, sir. A
Yeah, simple. You see this 16 kg object connected to 20 kg object. Very good. So if the 20 kg object is moving with an acceleration of simple a, 16 kg object should also be moved with the same acceleration. But what about the moving directions there? They are moving directions.
opposite, sir.
Opposite. Opposite. 20 kg object is moving to your left hand side direction. 16 kg object is moving to your right hand side direction. Because of the string, they will be moved with the same acceleration. Because of the pulley, they will be moved to the opposite direction because you see the forces. So please draw this figure with the two tension forces and the accelerations. Draw the figure exactly like this and mark everything that I have marked. Draw the figure on your book there. Start. Draw it. I think you have drawn. So let me draw the figure on whiteboard. Right. If you want, please take a screenshot of the things that are written on the whiteboard because I'm going to erase everything. So if you want, please take a screenshot. Okay, let me draw the boxes separately. If I consider this 16 kg box, it is moved by this tension force capital T. It is moved by this tension force capital T into this direction with an acceleration of simple a meter per square seconds. So only to 16 kg object to this direction, I apply F equals mv. So when you write this equation, it's better if you draw this 16 kg object separately. The only horizontal force acting on the 16 kg object is capital T. Its mass is 16. Acceleration is simple a. Let me mark it as first equation. So I would like if you write down everything. So this is question number 14. I know that you have already drawn the complete figure, but if you draw this separately, it will be easy for you to understand. So draw it there and write down everything. So today I'm so happy because my sisters, daughters are here. So I'm so happy today. Right. Let's do the same thing to the next object. Right. Look at board. If you consider this 20 kg object. Here, this time I draw only the horizontal forces because they say they have given that surfaces are smooth. So why should I worry about the R and mg and friction? So I just consider only the horizontal forces. There is a horizontal force of 6 Newton acting into my left hand side. That's the force of capital T Newton given by the spring into my right hand side direction. So only, look at board, only to 20 kg object to this direction, I apply the equation F equals mv. The only force acting, the force acting right hand side 6, force acting to left hand side capital T. So 6 minus capital T equal mass is 20, acceleration is simple a. Let me mark this as the second equation. Write this, draw the figure, write the equation. Here I have marked only the horizontal forces. Start here. Right. What should we do to find the acceleration, dear? What should we do? What should we do next, dear? What should be the next point? Hello? How do you find this capital T and acceleration? What should be the next
So
point?
subject the A.
Subject
Solve
A.
those equations simultaneously.
Solve the two simultaneous equations. How? What should we do next, dear? Yeah, we should solve the
Subject A,
simultaneous
sir.
equations, but how? Please tell me the method.
Instead of T,
1 plus 2.
Very good. Just add 1 and 2. What's your name, dear? What's your name?
2, sir.
Yeah, let's add 1 and 2. 1 plus 2. Look at board. The first equation, only capital T. The second equation, T plus 6. Sorry, T minus 6 minus T. Second equation, 6 minus T. First equation, T. Second equation, 6 minus T equals first equation 16A. 16A. Second equation 20 times A plus 20 times A. T plus 6 minus T. 16 plus 20. Here. 16A plus 20.
36.
36.
36 is
Is it that much difficult? 36. What will happen to this plus T and minus T? T and this minus T, what will happen? Cancelled out. So 6
Cancel out.
equals 36 times A because T and T cancelled out, plus T and minus T cancelled out. Let's take 36 to this side. 6 divided by 36 equals simple A. So simple A equals 6 divided by 6 is 1. 36 divided by 6 is 6. Unit is meter per square second. You must write the unit with the answer. Then only you will get the, you will earn marks. Complete. And if you have any further doubt, just unmute the mic and ask. Or send me a message to Zoom chat. And the other thing, after many days, after so many weeks, I send you a PDF of units and dimensions note. Did you see it? Today I sent it. Daruwane?
Yes, sir. Yes, sir.
Daruwanta hambunada
sir.
ekada?
Yes.
Hambuna.
Yes, sir. Yes, sir.
Ekada mama ewa units and dimensions note, right? A PDF with the correct page numbers. Okay, dear? Right. මේ ළමයි නිකමටවත් මට thank you කියලා reply කරේ නෑ ඒ උනාට. Hmm?
Thank you.
Thank you, sir.
sir.
Thank you.
Thank you, sir.
Actually, I created PDF 2-3 weeks ago, but I forgot it. 1 or 2 weeks ago, I created it, arranged it, but I forgot to send it to the groups. Welcome you all. Right. Okay, so shall we find the tension force also here? How do you find tension force? Give me a method. We found the acceleration of the system. How do you find the tension?
By substituting
Yeah, tell me dear.
by substituting A, sir.
By substituting the value of value of simple A, right? So normally we write it like this. We say by using the first equation. The first equation tells us capital T equal 16 times A. First equation tells us the tension force capital T equals 16 times A. So 16 times A is 1 over 6. 16 divided by 2 is 8. 6 divided by 2 is 3. Therefore, the tension force is 8 over 3 Newton. In the examination, you have to divide this 8 by 3 and give it at least with 2 decimal places. But for my questions, never divide, because I want to practice how to work with fractions, something divided by something. I want to teach you how to deal with fractions. So keep the answer as fractions for all of my questions. Complete it, dear. Complete it. What do you think about question number 16? No, not 16, 15 actually. Eh? Shall we go to question number 15?
Okay, sir.
Okay, right.
Okay, sir.
Right. So student have given me the permission. So I'm going to go to question number 15. Can you see it?
Yes, sir.
Right.
Yes, sir.
Okay.
Yes, sir.
I'll read the question. Two metal balls of masses 6 kilogram and 9 kilogram are connected by a light string. By applying a vertical force of 160 Newton to 6 kg ball, the system is moved up with a constant acceleration. The masses of the two objects 6 kilogram and 9 kilogram. Find the acceleration of the system. Right. if you want, please take a screenshot and let me solve this problem. I'm going to solve the problem. You just look at board, because I think you in Sunday morning paper class also we discussed a past paper question very similar to this. Do you remember it, dear? Who joined Sunday morning class and remember this question?
Yes, sir.
Yes, sir.
Similar question, right? Similar question. So here also, light string. Light string means no mass. No mass. Let me draw it. Let me draw the figure. But before that, if you want, please take a screenshot of a whiteboard, because I'm going to erase everything. So if you want, please take a screenshot. Okay, let me draw the figure, but in not in this format. So let me use the word system. System. System means everything. The system means everything. For example, if you want, you can see me as parts. Right hand, left hand, head, neck, body, and legs. Or you can see me as one object, a human. Even though my parents don't believe me, you can think teacher is a human. So, or you can consider as parts: one hand, second hand, head, neck, body, and so on. Or you can consider everything. You can take everything together and tell a human. So here I'm not going to worry about the ball here. I'm not going to worry about the ball there. I'm not going to worry about this. I consider everything as a system, and I'm going to write mass of the system. Mass of the system. Let me take this as capital M equals mass of the first ball 6 kilogram, mass of the second ball 9 kilogram. Therefore, the mass of system is 15 kilogram. Mass of the system is 15 kilogram. So I have indicated mass of the system by capital M. Therefore, the weight of the system. Somebody unmute the mic and tell me if the mass of the system is capital M. If the mass of the system is capital M, what should be the weight of the system? Somebody? Hello?
10 M, sir.
Avunda?
So 10,
If
so
the
10
mass
into
of
capital
the
M.
system, listen carefully. If the mass of the system is capital M kilogram, what should be the weight of the system, dear?
Capital M
10
into
M, sir.
Capital MG. Ayyo, ekani.
M into
Capital M into simple G. The total force acting on the system is given as 160 Newton. 160 Newton. Under the influence of 160 Newton and capital mg force, do not forget to use capital M. Capital mg force, the entire system is moving up with an acceleration of simple a meter per square seconds. I am going to find this simple a. So for the question number 15, draw this figure with these dotted lines, indicate it as a system, and write the mass of the system as 6 plus k 9. So I'm going to consider everything together as a single object. The single object is said to be the system. Draw it. Draw and write down everything that I have written on the board. And how is our chemistry class, dear? Our Senanayaka sir's chemistry class, how was it?
Excellent, sir.
Excellent.
sir.
So good.
Yes, any other comments?
Superb, sir.
Right. I'm going to ask you a question. I said that he's the best chemistry teacher in the island. Am I right or wrong? Saumika Senanayaka.
You're
You are
right.
right, sir.
100% correct or not?
1,000 times.
100% correct, sir.
Right. What is his class time, dear? Saumika sir's chemistry class?
Thursday, 6.
Thursday,
6 to 9.
6 to 9. What is the lesson?
Hydrogen.
Yeah, what is?
Hydrogen emission spectrum.
Hydrogen spectrum.
Hydrogen emission spectrum, right? Okay. So I have introduced the best chemistry teacher. So try to achieve a good rank. What about the trigonometry class, dear? Trigonometry, math students. I'm talking about math students, dear. How was it? ළමයි trigonometry නැතුව maths වලට A ගන්න නම් හිතන්න එපා. ඒක මේ ආත්මෙ වෙන්නේ නැහැ. කියලා වෙයි ඈ. You must learn trigonometry lesson with the best experienced teacher, right? සෙල්ලමක් නෙමෙයි හොඳේ. මං කිව්වේ නැහැ කියලා නම් කියන්න එපා. Okay? Right. Yeah, there are many good teachers, but for the students Kandy, Kurunagala, Mavanalla, Kagala, Matale, Nuwarelia, for those areas, the best is Anandi Langakon, sir. That's why I ask you to join to his classes, right? So trigonometry is very important. So please give your maximum effort. So those days we used a huge book for trigonometry. I don't remember the name of the author. And if you do it, that book, because Anasa is doing that book, you talk to him and ask the name of the book. So it's a huge one, right? This much of size. You have to do a lot of things for trigonometry, right? Right. How do you find this acceleration? How do you find the acceleration? Look at board. To the system, vertically upward, we apply the equation F equals ma. The upward force 160. What is the downward force? Somebody please tell me. What is the downward force? Capital mg. What is the downward force, dear?
150 Newton.
What is this?
Sir, 150.
Capital MG.
Capital MG,
The
sir.
downward force is capital mg. I wanted it. Capital mg. Mass is capital M. Acceleration is a. I wanted to indicate capital M. Capital M is the total mass of the system. Right. 160 minus capital M, 15. G is 10. This is 15. Acceleration is simple A. 160 minus 150 equal 15 times A. 160 minus 150 is 10 equal 15A. So if you take 15 to this side, you will get 10 divided by 15 equals simple A. So simple A equals 10 divided by 10 divided by 5 is 2, 15 divided by 5 is 3. So acceleration is 2 by 3 meter per square seconds. Complete it. I'll read the question. Two metal balls of masses 6 kilogram and 9 kilogram are connected by a light string. By applying a vertical force of 160 Newton to 6 kg ball, the system is moved up with a constant acceleration. The masses of the two objects 6 kilogram and 9 kilogram. Find the acceleration of the system. Right. If you want, please take a screenshot and let me solve this problem. I'm going to solve the problem. You just look at board because I think you in Sunday morning paper class also we discussed a past paper question very similar to this. Do you remember it, dear? Who joined the Sunday morning class and remember this question?
Yes, sir.
Yes, sir.
Similar question, right? Similar question. So here also light string. Light string means no mass. No mass. Let me draw it. Let me draw the figure. But before that, if you want, please take a screenshot of a whiteboard because I'm going to erase everything. So if you want, please take a screenshot. Okay, let me draw the figure, but in not in this format. So let me use the word system. System. System means everything. The system means everything. For example, if you want, you can see me as parts. Right hand, left hand, head, neck, body, and legs. Or you can see me as one object, a human. Even though my parents don't believe me, you can think teacher is a human. So, or you can consider as parts: one hand, second hand, head, neck, body, and so on. Or you can consider everything. You can take everything together and tell a human. So here I'm not going to worry about the ball here. I'm not going to worry about the ball there. I'm not going to worry about this. I consider everything as a system, and I'm going to write mass of the system. Mass of the system. Let me take this as capital M equals mass of the first ball 6 kilogram, mass of the second ball 9 kilogram. Therefore, the mass of system is 15 kilogram. Mass of the system is 15 kilogram. So I have indicated mass of the system by capital M. Therefore, the weight of the system. Somebody unmute the mic and tell me if the mass of the system is capital M. If the mass of the system is capital M, what should be the weight of the system? Somebody? Hello?
10 M, sir.
Out there.
Sir, 10,
If
sir,
the
10
mass
into
of
capital
the
M.
system, listen carefully. If the mass of the system is capital M kilogram, what should be the weight of the system, dear?
Capital
10
M,
10
Newton.
M, sir.
Capital MG. Ayyo, ekani.
limit to
Capital M into simple G. The total force acting on the system is given as 160 Newton. 160 Newton. Under the influence of 160 Newton and capital mg force, do not forget to use capital M, capital mg force, the entire system is moving up with an acceleration of simple a meter per square seconds. I am going to find this simple a. So for the question number 15, draw this figure with these dotted lines, indicate it as a system, and write the mass of the system as 6 plus k 9. So I'm going to consider everything together as a single object. The single object is said to be the system. Draw it. Draw and write down everything that I have written on the board. And how is our chemistry class, dear? Our Sena Nayak sir's chemistry class, how was it? Many good teachers, but the can for the students Candy Kurunagal, Mavanal, Kagal acceleration. Look at board to the system vertically upward. We apply the equation F equals ma. The upward force 160. What is the downward force? Somebody please tell me. What is the downward force? Capital mg. What is the downward force, dear?
150 Newton.
What is this?
Sir, 150.
capital MG. Capital MG,
The
sir.
downward force is capital mg. I wanted it. Capital mg. Mass is capital M. Acceleration is a. I wanted to indicate capital M. Capital M is the total mass of the system. Right. 160 minus capital M. 15. G is 10. This is 15. Acceleration is simple a. 160 minus 150 equal 15 times a. 160 minus 150 is 10 equal 15a. So if you take 15 to this side, you will get 10 divided by 15 equals simple a. So simple a equals 10 divided by 10 divided by 5 is 2, 15 divided by 5 is 3. So acceleration is 2 by 3 meter per square seconds. Complete it. Is everything clear? Right. I think you have written everything. Let's try to discuss the rest of the question. If you have any further doubts, you can ask before I show you the rest of the questions. Do you have any other difficult points there? Should I explain any of these things further?
So it's okay.
Right. Everything is okay. So let me show you the rest of the question. That is question number 13 we completed, 14 completed, 15. So Roman number 1, find the acceleration of the system. We have answered it, right? We have found the acceleration of the system. Okay, somebody unmute the mic and read Roman number 2 and Roman number 3. 2 and 3 questions.
Draw the free force diagrams of the objects and the string. What are the tension forces acting at?
Right, they asked us to draw the free force diagrams. Free force diagrams means we should draw all the forces acting on each object separately. What should we do? We should draw all the forces acting on the object separately. Right. So now I'm going to discuss it. Look at board carefully. I'll explain everything. Don't worry about this. If you want, you can take a screenshot if you want the questions, but I'll send you this tute. Okay. So we have drawn the complete diagram. Everything we have considered as a one object, and we have applied F equal ma to find the acceleration. That's what we did. Now we are going to draw the free force diagrams. Right. Look at board carefully. So if I consider this 6 kg object, it's moving up with an acceleration of, I forgot the acceleration. Somebody please tell me the acceleration of the system there. Somebody in the class?
2/3 meters.
2/3 meter per square second. So everything is moving with the same acceleration of 2/3. So acceleration of this is 2/3 meter per square seconds. So according to Newton's first law of motion, for an object to be moved with an acceleration, it needs an external unbalanced force. So what is the external unbalanced force acting on this 6 kg object? Somebody unmute the mic and tell me. Somebody unmute the mic and tell me what is the external force acting on this 6 kg object to be moved with an acceleration of 2/3 meter per square seconds. Somebody in the class?
4 Newton.
Sorry, again?
4 Newton.
4 Newton. Check again. This 160 Newton force is directly acting on the 6 kg object. The 6 kg object is moved up because of this external vertical force of 160 Newton. Okay or not? Ah? Okay, right. Then the string. Somebody unmute the mic and tell me why this string is moving. There are two reasons for the string to be moved. So what is the first reason for this string to be moved up?
Because the string connects the two objects.
Because the string is connected to the 6 kg object. Because the string is connected to the 6 kg object. When the 6 kg object is moving up, it is pulled the string upward by giving a force. When the 6 kg object is moving up, it pulls the string upward by giving a force. The 6 kg object is connected to the string. First reason, when the 6 kg object is moved up by this force, this 160 Newton force, the 6 kg object pulls the string upward by giving a force. Let me mark that force. Let me mark that force as T1 Newton. Who gives this T1 Newton force, dear? Unmute the mic and tell me who gives this T1 Newton force.
6 kg object.
6 kg object. Now somebody unmute the mic and tell me Newton's third law of motion. Newton's third law of motion.
Every action has
Every action
opposite.
has equal and opposite reaction. So if the 6 kg Newton force, if the 6 kg object gives a force of T1 Newton to the string should give equal and opposite reaction force to the 6 kg object. The equal and opposite reaction force given by the string to the 6 kg object. Let me mark it as F1. So this F1 and T1 equal in magnitude, opposite in the direction. They are the forces explained by Newton's third law of motion. Action force, reaction force. Okay? And after you have drawn the figures, I'll give you a further description. I'll explain this further again. Now look at board. Why this 9 kg object? This 9 kg object is also moving up with the same acceleration of 2/3 meter per square seconds. Why is this object is moving up? Why is it moving up? Somebody unmute the mic and tell me the reason. Hello? There are two reasons actually.
As the 9 kg object is connected to the
Very good. The first reason, 9 kg object connected to the string. Second reason, as they are connected together, when the string is moving up, it pulls the 9 kg object up. It means the string is giving a force to the 9 kg object. Let me mark that force as F2 Newton. Who gives this F2 Newton force? Unmute the mic and talk to me. Who gives this F2 Newton force, dear?
string.
The string gives F2 Newton force to the 9 kg object. Now somebody unmute the mic and tell me Newton's third law of motion. Newton's third law of motion.
Every action has an equal and an opposite reaction.
Every action has equal and opposite reaction force. So when the string gives a force of F2 Newton to the 9 kg object, the 9 kg object should give equal and opposite reaction force T2 Newton. This is action force, T2 is the reaction force. These T1 and T2 forces are said to be the tension forces. What are they called here? This T1 Newton force and T2 Newton force are said to be the tension forces in the string. As the string does not have a mass, actually T1 and T2 are equal. But I am going to prove that T1 equals to T2. I am going to prove it. In addition to the FEX force and F1 force, another force is acting on the 6 kg object. What is that force, dear? In addition to 6 kg, this FEX force and F1 force given by the string, another force is acting on the 6 kg object. What is that force? Somebody? Sorry?
Gravitational attraction.
Gravitation attraction force. Very good. Gravitation attraction force. So let me mark the gravitation attraction force acting on this object as M1G Newton. M1G Newton is the gravitation attraction force acting on this object. Similarly, in addition to this F2 force, another force is acting on this 9 kg object. What is that force, dear? In addition to F2, there must be another force acting on the 9 kg object. What is that force?
Gravitational attraction.
Gravitation attraction force. So let me mark the gravitation attraction force acting on the 9 kg object as M2G Newton. Please draw the free body diagrams. After you have drawn, I'll give you further description and I'll again explain. Draw the figures, mark everything that I have marked on the figures. Quick, dear, start.
Okay, sir.
Right, I think you have drawn them. Right. Look at board. Look at board. Please write in the point form these descriptions, very important. So please write the descriptions. They will be very important for you. Okay. So please write. If you want, you can write star points and write. 6 kg object is moved up. Write in the point form. 6 kg object is moved up by 160 Newton force. 6 kg object is moved up by the 160 Newton force. By the 160 Newton force. Full stop. 6 kg object is moved up by the 160 Newton force. By the 160 Newton force. Full stop. Next line, next point. As the string is connected to the 6 kg object, as the string is connected to the 6 kg object, as the string is connected to the 6 kg object, comma, as the string is connected to the 6 kg object, comma, when the 6 kg object is moving up, when the 6 kg object is moving up, when the 6 kg object is moving up, comma, as the string is connected to the 6 kg object, comma, when the 6 kg object is moving up, comma, it pulls the string upward, it pulls the string upward, it pulls the string upward, it pulls the string upward by a force of T1 Newton, by a force of T1 Newton, when the 6 kg object is moving up, comma, it pulls the string by a force of T1 Newton. If you want to repeat, please tell me. If you want to repeat, please tell me. Right. Next line, next point. According to Newton's third law of motion, according to Newton's third law of motion, comma, according to Newton's third law of motion, comma, when 6 kg object gives a force, according to Newton's third law of motion, comma, when 6 kg object gives a force to the string, when 6 kg object gives a force to the string, comma, the string should give equal and opposite reaction force. When 6 kg object gives a force to the string, comma, the string should give equal and opposite reaction force to the 6 kg object. Should give equal and opposite reaction force to the 6 kg object. 6 kg object. Full stop. That force is marked as that force is marked as simple F1 on the 6 kg object. That force is marked as simple F1 on the 6 kg object. Right. Who would like if I repeat the note? Anybody in the class? Okay, now I'll give you a chance to read the note. Somebody in the class, please read the note from the very beginning, slowly, clearly, loudly. Start, somebody.
Six kg object is moved up by 160 Newton force. As the string is connected to the 6 kg object, when 6 kg object is moving up, it pulls the string upward by a force of T1 Newton. According to Newton's third law of motion, when 6 kg object gives a force to the string should give equal and an opposite reaction force to the 6 kg object. That force is marked as F1 on.
Yeah, that force is marked as F1 on 6 kg object. Thank you, dear. I would like if one more student read the note from beginning to the end, slowly, loudly, neatly. Don't waste the time. Quickly unmute the mic and read the note from the very beginning. One more student.
The 6 kg object is moved up by the 160 Newton force. As the string is connected to the 6 kg object, when the 6 kg object is moving up, it pulls the string upwards by a force of T1 Newton. According to Newton's third law of motion, when 6 kg object gives a force to the string should give equal and opposite reaction force to the 6 kg object. That force is marked as F1 Newton on the 6 kg object.
Right. Is it clear or may I explain it again? Two students helped us. Right. Okay. Right. So please write. Please write. The string is connected to the 9 kg object. The string is connected to the 9 kg object. The string is connected to the 9 kg object. Full stop. Therefore, the string is connected to the 9 kg object. Full stop. Therefore, when the 9 kg, when the string is moved up, therefore, when the string is moving up, when the string is moving up, comma, it pulls the 9 kg object by giving a force of simple F2 Newton. It pulls the 9 kg object by giving a force of simple F2 Newton. The string is connected to the 9 kg object. Therefore, when the string is moving up, it pulls the 9 kg object. It pulls 9 kg object by giving a force of simple F2 Newton. Full stop. Leave a line and write. According to Newton's third law of motion, leave a line and write. According to Newton's third law of motion, comma, 9 kg object. According to Newton's third law of motion, 9 kg object gives equal and opposite reaction force to the string. According to Newton's third law of motion, 9 kg object gives equal and opposite reaction force to the string. Equal and opposite force to the string. That reaction force is marked. That reaction force is marked as capital T2 on the string. That reaction force is marked as capital T2 on the string. Right. Now somebody unmute the mic and read that note also from the very beginning. Somebody quick.
The string is connected to the 9 kg object. Therefore, when the string is moving up, it pulls the 9 kg object by giving a force of F2 Newton. According to Newton's third law of motion, 9 kg object gives equal and opposite reaction force that is marked as
So a string is connected to the 9 kg object. So when the string is moving up, it pulls the 9 kg object by giving a force of simple F2 Newton. According to Newton's third law of motion, 9 kg object should give equal and opposite reaction force to the string. I have marked that force as T2 Newton. Right. Next star point. In addition to the above forces, next star point. In addition to the above forces, comma, gravitation attraction forces given by the earth, in addition to the above forces, comma, gravitation attraction forces given by the earth are marked as M1G and M2G. In addition to the above forces, comma, gravitation attraction forces given by the earth are marked as M1G and M2G. If you want to repeat, please tell me. If you want to repeat that point, please tell me. Anybody in the class? Okay, now look at board. We can find F2 by applying F equal ma to the 9 kg object. If we know F2, we know that F2 equal to T2, that is Newton's third law of motion. Look at board. Look at board. Only to 9 kg object vertically upward, I apply the equation F equals ma. Only to 9 kg object vertically upward, I apply the equation F equals ma. The upward force acting on the 9 kg object is F2. The downward force acting on the 9 kg object is M2G Newton. Thus, the total upward force is F2 minus M2G. The total upward force acting on the 9 kg object is said to be the resultant force. What is the term that we use here? Resultant force. Resultant force acting on the 9 kg object is F2 minus M2G. Mass is 9. Acceleration is 2 by 3. Acceleration is 2 by 3. We don't know what the F2 is. M2 is 9. G is 10. 9 divided by 3 is 3. This is 2. F2 minus 9 times 10, 90. 3 times 2, 6. F2 equals 6. Minus 90 comes to this side as positive 90. Therefore, F2 equals 96 Newton. F2 equals 96 Newton. But we know that F2 and T2 are action-reaction forces given by Newton's third law of motion. Therefore, if F2 is 96 Newton, T2 is also 96 Newton. So therefore, T2 equals 96 Newton. T2 is 96 Newton. Completed here. Write them all. And if you have any further doubt, just unmute the mic and ask or send a message to the Zoom chat. Start. Right. The next thing is finding the force T1. So look at board. To find T1 only to 6 kg object. Only to 6 kg object. Vertically upward, we apply the equation F equals ma. If you consider this 6 kg object, there is only one upward force, and there are two downward forces, M1G and F1. M1G and F1. So, the upward force Fex, summation of the downward forces M1G and F1. Can you understand? Upward force Fex, the sum of the downward forces M1G plus F1. Therefore, the resultant upward force is upward force minus summation of the downward forces. So what is this here? The forces, this square bracket shows the resultant upward force. Upward force minus summation of the downward forces is the resultant upward force. The mass is 6 kilogram. Acceleration is 2 by 3. Acceleration is 2 by 3. Acceleration is 2 by 3. Fex is 160. Let me remove the brackets. Then I'll get minus M1G minus into positive minus F1. 6 divided by 3. 6 divided by 3 is 2. And this 2 will be there. 160 minus M1 is 6. G is 10. Minus F1 equals 2 times 2, 4. 160 minus 60 minus F1 equals 4. 160 minus 60 is 100 minus F1 equals 4. If I take 4 to this side, 100 plus 4 comes this side dash minus 4 minus F1 goes the other side dash positive F1. Then I'll get F1 equals 100 minus 4 is 96. But we know that F1 and T1 are equal. F1 and T1 are equal. So therefore, the tension force is also 96 Newton. So we have clearly proved that. Both T1 and T2 tension forces are equal, 96 Newton each. Got it? So when a connecting rod or a string does not have a mass, the tension forces at the ends are equal. Complete. So we have completely answered question number 15. Okay, completed there. I think that's enough for today. Please try to answer the rest of the questions at home. Right? So try to answer the other questions at home. If you have written all the things, now you can leave the class. See you. Bye. Good luck.